Okay, we're going to be looking at vertical and horizontal stretches and compressions of sine waves, okay? So, yesterday we talked about what the values or these variables C and D will do to a wave. C will horizontally shift the wave left and right. D will vertically shift a wave up and down, okay? We're going to focus on A and K today. Now, A is very similar or almost exact to the A in vertex form of a quadratic. It's going to vertically stretch our parabola. So it's going to take it up and down depending on what the A value is. So let's write an equation here. We'll say that y is equal to 3 sine x. Okay? What's going to happen here is we're going to multiply each of the y values, okay, every y value, by 3. So I've written this little coordinate multiplication and division thing to help you guys out. So if we have an a value that's other than 1, we multiply it by our y value of each of our coordinates. So always make this your first step. Okay, so if you have an entire equation and there are values of c and d, just do all your stretches and compressions first. It's usually easier. You don't have to, but it will make things simpler for you. So for instance, one of the coordinates is 90 and 1. Well, what's the y value here? 1. So we're going to multiply it by what? By 3, because that's the a value. So what's our new coordinate going to be? 90 and 3. That's right. So we have 90 and 3. That's a simple one. I didn't want to do the origin yet. Now we're going to do the origin. 0 and 0. I multiply 0 times 3. What do we get? 0. So the coordinate is still 0 and 0. So what's going to happen is the equation of the axis is essentially the same when there's just an A stretch or compression. Okay? So 180, what's going to happen to that? It's going to stay there because its y value is 0, so 0 times 3 is still 0. Negative 1 times 3, what's that going to do?
Negative 3. Go down negative 3.
That's right, it's going to go down to negative 3. Okay, so our equations of the axis are the same, and our other coordinates have been stretched by a factor of 3. So it goes up, and comes down, and goes up again. And then we continue that pattern on the left side. Okay. And this is a vertical stretch of our sine wave. Okay? So that's what a value of A when A is greater than 1. Okay? They'll give it to you. They'll give you this, okay?
So if it's 3, multiply 2 by...
Exactly, by all the y values. Now let's say our A value is between 0 and 1. Okay? So let's say I have an A value where an equation says something like y is equal to 1... No, let's say a half. Oh yeah, same thing.
Yeah, 0.5.
Okay, a half or 0.5, right? So this is 0.5. We do the exact same thing. We'll do this one in purple. Now our 0 values, or our equation of the axis, are still going to be all
0.
at 0. Okay, so none of these are going to change. For the coordinates that aren't on the y-axis, what's going to happen to them?
Multiply
By
by 0.5.
0.5. So what happens? It goes... It gets compressed, right? Just like we talked about before with the quadratic. So this shape is starting to do this type of effect. Okay, I'm estimating where a half would be. So this is a compressed sine wave. So this has been vertically compressed. Okay, so I'm putting arrows to show that it's gone down, where when A is greater than 1, it has been stretched from the original black one. Okay, and the only other one for A we need to talk about, y equals, when A is a negative value. Okay, when A is a negative value, you're going to flip the wave. So I could show you when A is negative 1, but I want to give you an idea of when it's a negative value that actually stretches or compresses. So what number would you guys like to work with?
2.
2? Sure. So let's go with negative 2. Okay. And we'll do this one in blue. Now it's going to be a little hard to see on this graph. Okay. Would you like me to graph? Sure.
Alright, we're back!
Okay, so here's, we're going to do it in green actually. So we have a negative value. So it's still the exact same idea. With all of our y coordinates, we just multiply the y values of each of these major points by negative 2. So what will 1 times negative 2 be? It'll be negative 2. So this y-coordinate now drops to here. 0 is still,
0.
and 0 is still 0. So if you notice, it has become inverted from where it was before. When we multiply negative 1 times negative 2, we'll get positive 2. Okay? Yeah, same idea. All it is it inverts. So if a is a negative value, it kind of makes an inversion of the original that we had. Okay? So keep that in mind when going through this. Okay. So those are our movements when we have a values. Okay, now we're going to focus on the k value, and I'm just going to quickly show you, sorry, the original again. This is where k would show up. It would be outside of your bracket if there was a c value, okay? For our sake, it's always going to be outside of the bracket. And some math questions may not be like that. You'd have to common factor, but it's fine. For what we do, we'll do it like this. So, let's go back to our other page. We have our original sine wave here. It's the same process to figuring out the k. We have a little cheat sheet here that'll find our coordinates. So what we do with each of our x coordinates, because k will horizontally compress and stretch this, okay? We're going to divide each of our x values by k. So this is when k is greater than 1. Okay, so k is greater than 1. For instance, we have the value of 2. So we get each of the x coordinates and divide them by 2. So my first x coordinate here, that origin, scroll down, actually I'll do it up here, is 0. So what is 0 divided by 2?
0.
Still got 0. So is that coordinate changed at all? Still right there. Now my next major coordinate was 90 and 1. I divide 90 by 2, what do I get? 45 and 1. So my next coordinate is at 45, which is halfway there, and 1. Then we take 180. 180 divided by 2 because our k value is 2, and it's 180 and 0. When I divide 180 by 2, what do we get? So we get 90 and 0. So if you notice, already this is starting to make a compressed from what we had before. Anyone know what 270 divided by 2 is?
180.
135, which is between 90 and 180, okay? So it's going to be here. And 360 divided by 2, Jerwin? 180, that's right. So that'll be there. So this is where our period occurs twice as often now. Okay, so our period has changed. K will be the only thing that will change the period of a function. And then we would continue that pattern. Okay, so it looks like it goes up, comes down, comes up. So where we used to have one period, oh jeez, it's okay, it's okay. Where we used to have only one period, I'm not sure what's happening, let me fix that.
We're back.
So we're back. So like we were saying before, the period used to be 360, but because our k value was 2, it compressed it. So we now have 2 periods in 360 degrees. The period is sliced in half. Then we would just continue that pattern like we said. Okay? And that's for when k is greater than 1. So that's kind of the opposite mentality. Remember when a was greater than 1, it looked like it stretched it? Here it compresses it. When k is greater than 1, we compress. Okay? Just like, remember how C and D were opposite when we're horizontally moving them and vertically moving them? Same idea with A and K. What about when K is less than 1? So we have a value of something like sine, let's say, third, go times 3. Put our x in here. Let's say we're multiplying times a factor of, I think 4 would be, actually, no, it won't fit on our graph. We'll go by 3. Okay? Sorry, a third. What we do here is we divide, again, all of our x coordinates by a third, which can be tough. You only have to really take a calculator. But what that's going to do, because it says it's x divided by k, well, when k is a fraction, I'm going to show you a trick here, divided by a fraction, all that happens is this 3 ends up being multiplied by the value on top. So it ends up being 3 times x. So all of our x values, we'll do this one in red. Okay? So we're going to do this guy in red here. Each of our x values are multiplied by 3. So our first one at 0, we multiplied by 3, we still have 0 and 0. 90 times 3 will be 270. So that's our next point. It's going to be at 270 and 1. And then, obviously, 180 is not even going to be on this chart, but it's going to make this effect.
Oh, well.
Okay? So this is very stretched from what we had before. Okay? And then we do the same thing this way. We have a very horizontally stretched wave. And finally, the last thing, if k is a negative value, okay, for instance, y equals sine, and we'll do -1 just to show you what this does. So -1. What's going to happen is it just inverts everything. Okay? So we multiply our x values by a negative value. So this times -1, well, it's just going to be 0 again. So this point stays. 90, sorry, it's divided by -1. It's going to be -90. So our 1 value is now at -90. Okay? 180 divided by -1 is going to be -180. So if you look, it's making this. Oh, don't do it again, please. Okay, I'm going to just keep going. It's going to make this type of effect. So it's going to flip it. Okay? Almost looks like a DNA chain. I know that's a little confusing. So that's what our k values will do.